Welcome to my channel. This series of video is mainly for how to write a program in an efficient way. Okay, that is mainly for time efficient. Okay. So already we have one video about this program. Okay. Now we are trying to improve the timing. We are trying to improve the timing. Okay, that is we are reduce the time complexity. Okay. So already that video link is available in the description box. So if you want, just click and view the video. So concept is small, okay, but we are discuss about very big concept here. There is the programming logic is somewhat simple. There is prime or not. To check the given number is prime or not. Okay, but we are talk about the time complexity. Okay, we are talk about the time complexity. Okay, so a small overview about it, about the previous video. So whenever we are going to use this logic, that is to check the primality of the number up from 2 to n minus 1 times. Okay, the loop should be executed this many times. This loop should be executed this many times. Okay, so to get that value, for that purpose I am using one statement, message statement here. Okay, that's why it should be executed this many times. Okay, so to reduce the number of execution time, okay, in this video we are going to repeat the loop n minus 2 minus 1 times. N divided by 2 minus 1 times. Okay, so we are going to repeat it this amount of time. Okay, so by default the divisibility rule is says to us after n by 2 no number is divide the no one is going to divide the number exactly. Okay, this is divisibility rule. Okay, so using that rule, we are going to repeat the execution n by 2 minus 1 time. That is less than or equal to n by 2 times. Okay. So totally, whenever we are using this logic, okay, there is no need to extend up to n minus 1 time. Okay, there is no need to extend n minus 1 time. Okay, so maybe we are take the sample as 17. Okay, 17 by 2. Okay, 17 by 2, that is 8.5. Okay, in integer division that is 8. Okay, that is 8. Okay, 9 cannot exactly divide 17. Okay, 17 divided by 9. Okay, it returns the quotient as 1 and remainder as 8. The remainder as 8. Afterwards, no number is going to divide the number exactly. Okay, so when it take 10, 17 divided by 10, it returns the quotient as 1 and remainder as 7. Okay, when it take 11, it returns the quotient as 1 and remainder as 6. Okay, likewise. Okay, so using that we are trying to reduce the number of times. Okay, so here we are going to check the number is exactly divisible by the current I or not. Okay, so always this modulus operator is going to return the remainder. Always it's ready to return the remainder. So whenever we are using this technique, it's going to repeat from 2 to 8. Okay, we are cut short our execution half of our number. Okay, only we are going to execute up to half of our number. And here also there is a need for to change it. Okay, so up to n by 2 we are going to check it. Okay, if the number is prime, okay, it's required n by 2 plus 1 times. Okay, afterwards only we can decide after the exact division of by 2. Okay, after the half of that number. Okay, we can decide that number is not divisible by any number, exactly divisible by number, so it's a prime. Okay, that's why I am here check it. Okay, whether the I value is greater than n by 2. Okay, if it is greater than n by 2, we can strongly say the given number is a prime number. Okay, so when I check it, okay, when I go with n minus 1 times, okay, the loop is executed this many number of times. Okay. When I use the divisibility rule, okay, that is division theory says after n by 2 no number is ready to exactly divide any number. Okay. So when I use that specific rule, okay, we can reduce number of execution of this block. We are reducing number of execution of this block. Okay. So let's execute, okay, and also get the difference. Okay. This is previous looping variable, that is we are previous concept. Okay, we are going to repeat the loop n minus 1 times. Okay, we are going to repeat the loop n minus 1 times. Okay, so when I do that n by 2 times, okay, what's the output? Let's check. See here, okay, that should be when I use 17. Okay, there is a need to repeat the loop 15 times, then only I can say the given number is a prime. Okay, when I use this concept, I am going to repeat the loop only 7 times. I am going to repeat the loop only 7 times. Afterwards, I can find afterwards, okay, simply I can say the given number is prime. Okay, the given number is a prime. Okay, okay, let's check with 35. Let's check with 35. The exact half number is 35 is 17. Okay, the exact divisible number is 17. Okay, so it's going to, okay, based on our view, it should be going to repeat 2 to 17. Okay, our loop is going to repeat 2 to 17. Okay, but 35 is exactly divisible by 5. Okay, 35 is exactly divisible by 5. Okay, so when I divide here, okay, true block, that is 35 modulus 5, it returns the remainder as 0. Okay, so automatically it says it's not a prime. Okay, so when we are using the break statement, automatically we can come out from the for loop, okay, and check the condition. I is greater than n by 2. Currently I value is 5. Okay, but our n by 2 is 17. So I is less than, so it doesn't get the wave. There is compiler doesn't execute this specific line. Okay, so we can come out from the program. Okay, so the program going executed like that. Okay, so how many times we can get this statement, this message? Okay, when I value is 2, that time we can get once. I value is 3. Okay, then I value is 4. When I value is 5, automatically it's come out. Okay, so only we are going to repeat this loop 4 times alone. Okay. That's why we can get 3 times we are inside the for loop. Then it simply says 35 is not a prime. Okay, if it is not a prime, we can simply get it. Okay, when it's a prime number, that time only the loop is going to repeat for a long time. Okay, so 37 is a prime number. So see here, how many times it's the area should be executed. Okay, that is the block, for loop block is executed 3, 6, 9, 12, 15, 17 times. Okay, so whenever we want to reduce the number of times, we can use some specific logic. Okay, we should find some logic that should reduce the number of time execution. Okay. In the next video, we will see some more reduced way of execution. That is, we have reduced the time complexity. Okay, and we are going to I'm going to use some other techniques. Okay. It's reduce the execution time. So that's also inside that video, also added in the description box. So if you want, you can check the description box. Thank you for watching the video.